Everyone. I just want to make sure that we kind of talk about question 3 again, where we left off discussing that we were going to have an activity. So due to time constraints, I just wanted to touch base with you and remind you that this is section 1.2, and there's going to be a homework assignment question 1.2.21. That is exactly the same question. So I just want to make sure that we all know how to do it. So the question is asking, let A of X be the area of the region bounded by the t-axis and the graph of y equal f of t from t equal to 0 to x. Consider the function and its corresponding graph below. Find A of 2, A of 6, and the formula for A of X. So the first thing that you want to do is what we did in class. We actually separated this between a rectangle and a triangle. But if you recall, if A is equal to 2, that means that your axis will be cut here at 2. If you turn it sideways, this is a trapezoid. And the trapezoid, now the height, this height of the trapezoid is going to be 2, whatever the x is. So this will have a height of 2 with a base, with one of the bases being 4 and the other base being the 8. So this is little b and big B. So we are going to use this area of a trapezoid, big B plus little b over 2 times the height. In this case, the height is going to be equal to 2, or x here, this purple. That's the height. We have base 1, and then over here, base 2, or in this case, I called it big B and little b. So A of 2 will be, so here my height is equal to 2. My base 1 is equal to 4. Base 2 is equal to 8. So let me change my formula here. It's going to be base 1 plus base 2 over 2 times my height. So then I'm going to use that formula to evaluate A of 2. So A of 2 is 4 plus 8 over 2 times 2. That is equal to 12. That's the answer we also had in class. So we could do it both ways. However, I wanted to kind of show it to you in a better format because we're going to use that in part C. Now, what happens when we're looking for A of 6? So we are going to now find what is A of 6. So we are now in A of 6. So A of 6, we are going to go and we're going to bound it all the way over here. So A of 6 would be now this orange one. So let me erase the other one that we had. And we are going to go into the orange. Now the orange, let me erase this one and let me make this orange. Now I'm finding this, this orange one. Let me get rid of this purple. Let me get rid of the purple one. Now we're doing A of 6, which is A of 6 right here. But we're going to have a trapezoid here. We're going to have a trapezoid here with now the height is 3. So the height, instead of being 2, is going to be 3. And my base 1 is going to be 2. My base 2 is going to be equal to 8. So now my formula will change with just my trapezoid. And that's going to be 8 plus 2 over 2 times 3. This is the height. This is the height. This is base 1 plus base 2 over 2. Base 1 plus base 2 over 2, that's the formula. That's 15. but 15 is just the trapezoid. I'm still missing this part. This part is a rectangle of base. My base is 1, 2, 3. My height, so my base is 3, my height is 2. So 2 times 3 is 6. So then I still have to add the area of the trapezoid plus the area of the rectangle, which is 3 times 2. So my total area is, my total area is 15 plus 6, the trapezoid with the height of 3 and 6 base times height is 21. So A of 6 is going to be 21. Now we are going to find a general formula that will calculate the whole thing, the whole function. We want to bound the whole function. When we bound the whole function, we need to notice that what happens before 3 and after 3. So before 3, we only have a trapezoid. And remember, this t-axis is actually x. So this t is equal to x. We know one of the bases is 8. That's base 2. And base 1 is going to be 8 minus 2x. The height minus 2 times x, where x is, it ranges, right? So this area before 3, the area of x when x is less than 3, including 3, because I'm including 3, we just saw that, is going to be 1/2 times b1 plus b2 times my x. My x is the height. We don't know what the height is. It depends on my x. So if I plug it in, I have 1/2 times, so base 1 is 8 plus 8 minus 2x times x, where x is the height. Now, if I combine, I have 1/2, 8 plus 8 minus 2x times x. The inside is 16 minus 2x times 1/2 times x. This is 8 minus x, and then times x is 8x minus x squared. This is the general formula for the values of x being less than or equal to 3. That is a generalized formula. Now, what happens after 3? Well, what happens after 3? So when x is greater than 3, you're going to have the trapezoid so here this value is 8 minus 2x. If I'm counting also these two pieces, including this part, and now I'm going to have to remove this part, which this is already a of 3. We know a of 3 was 15. That just trapezoid. And what I have here remaining is base times height. My base is 2. It will stay as 2. My height in this case will always be 2, but my base will change from, if the whole thing is t, it's going to be t minus 3, because I'm removing the 3, or in this case, it's x minus 3. because t is a function of x. So now to find what happens when x is greater than 3, well, you have to take a of 3, and then we are going to add 2 times x minus 3. So a of 3 is 15 plus 2x minus 6. I get 9 plus 2x. So then this is a piecewise function in terms of a of x. And the first piece is 8x minus x squared when x is strictly less than or equal to 3. And when x is greater than 3, you'll have a 2x plus 9. And that is the general form. So we have to include the 15. Will it stay the same? We're adding that piece to base times height. The height will always be 2 here, this height, but what's going to change is actually the base. So the base is going to be x minus 3. Why minus 3? Because we're taking the first 3 into consideration. That's why it's x minus 3. And that is my solution to this question. And I wanted to do that activity in class to kind of identify what happens when we use a trapezoid. So the activity was to do it in a different format. Instead of doing a triangle and a square, we just can combine that as a trapezoid. So that was kind of the realization. Okay. I also want to make sure that I discuss transformations with you because we didn't have the chance to talk about that. So in addition to section 1.2, I want to discuss transformation of functions. And again, this should be review, but we begin with vertical shifting. What is a vertical shifting? We are going to take our original function and we're going to add k units. So k means if k is greater than 0, it will shift upward. If k is less than 0 or negative, you will shift downward. Upward k units or downward k units. So I'm going to do an example. If I have the function x squared minus 3, remember that f of x squared is a parabola that opens up like this. If I have x squared minus 3, that means that k is equal to negative 3. That means you're going to shift down 1, 2, 3 from the original vertex. And now your parabola will start below. The shape will stay the same. Another example is, let's say we have another function and we have, let's say that f of x is equal to the square root of x, but we have a transformation that says the square root of x plus 4. Now the outside k value is 4. So your original function f of x, so this would be f of x plus 4 is equal to the square root of x plus 4. So instead of the original function, the square root of x goes like this. If you have the square root of x plus 4, you go 1, 2, 3, 4, and then you start here. So every vertical component will add by 4. Here, every vertical component will decrease in value. My y value will decrease by 3. That is vertical shifting. We also have something called horizontal shifting. A horizontal shift. That means when you have f of x plus h or f of x minus h. So here, you're going to shift to the left H units, and you're going to shift right H units. So it matters if it's a plus or minus. Let's do an example. If I have f of x is equal to x plus 3 quantity squared, that is a shift to the left 1, 2, 3 units, and you're going to shift it horizontally. Your parabola, instead of being here at your center, it's going to shift 1, 2, 3 to the left. Now, another example, if you have f of x to be equal to the square root of x minus 3, now instead of starting here at 0, 0, you're going to shift to the right 1, 2, 3. Your x values, all of your x values will shift to the right side, H units. So that is vertical shifting, horizontal shifting. We also have a vertical stretch. That means that if you have a of f of x, so if a is greater than 1, it's going to stretch. If a is in less than and between 0 and 1, you are going to compress. What does that mean? So let me do an example. If I have 5x squared versus 1/5 x squared. So here, a is equal to 5. That means that 5 is greater than 1. It's going to be a stretch, a vertical stretch. So it's going to go faster to infinity. So here we have our normal x squared. My 5x squared, you can play around with your calculator. 5x squared, you're going to vertically stretch. Whereas 1/5, when a is 1/5, this is less than 1. In between, it's a fraction. So here you have your original x squared, and when you have 1/5 x squared, it's like you're compressing it, you're pushing it down. See how this is pushed down? Again, you can play with your calculator and identify that. And that is a vertical stretch. We also have reflections. But for now, this is what I want to focus on. Vertical shifting, horizontal shifting, and vertical stretch and compress. Alrighty, so that's what I wanted to add, making sure that you felt comfortable doing this problem and identifying that we can also solve it using a trapezoid. So after looking at this video, you're going to have a short little quiz just about if you understood the recording. And that's it. Thank you, and I'll see you guys next time. I'll see you guys Wednesday of next week. Have a good night. Bye-bye.